All right, hi guys, welcome back to a new video. For this video, I'll be doing differentiation techniques, and this is very, very important. Okay, the first three videos that I did on differentiation, right, on the limits, on the understanding of gradient, as well as the last one, which is the first principle differentiation. Those I would say it's a basic, and it wouldn't be asked a lot. But this point onwards, right, they will ask a lot of questions on basically foundation from this part, starting from this part. So what I want you to do is to build your foundation from here correctly. You must be able to solve every question that I discuss after you have watched the video by yourself. You have got to be able to solve every of them and do the rest. All right. As I mentioned, timestamps in the description box below. And any questions, just ask me down there, or you can DM me. I'll soon create a Facebook community whereby we can actually include y'all in, and I can actually provide the answers for the undiscussed questions in this, in every chapter, basically, because some questions I wouldn't discuss. All right, so without further ado, we will move on. Okay, so I'll be going through power rule for this chapter, for this video. Okay, I will do in separate videos. I'll do power rule first, then I'll do product rule, then I'll do quotient rule, and I'll do chain rule last. And of course, we will do second derivative later. Okay, so anyways, we will do power rule first. What is power rule? Power rule basically means, right, when you have a function. Okay, one thing I want to explain to you first. Okay, all the differentiation that we will be doing will be only on polynomial functions. What do you mean by polynomial functions for this video is, polynomial function is actually functions involving polynomials. Basically, you have x power of something, x power n plus x power n plus 1, n minus 1 plus x power n minus 2. Okay, basically something like this. You don't see sine, cos, tangent. Okay, you don't see exponent, you don't see logarithm. Okay, basically we are not differentiating for this kind of function. We are only differentiating for functions that are powers, x power 4 plus x power 3 plus x power 2 plus x power 1, this kind of function. Okay, ax4 plus, basically this kind of function. You get what I mean, polynomial functions. Okay, so that's not so important. What is important is when you have a polynomial function of y equals to a power x, a times x to the power of n. And don't forget, now the variable is x and y. A is just a constant, n is just a power. Okay, when you differentiate this one, right, when you dy dx, right, what do you get is straight away you bring the n downwards, ax, you copy back, then you minus the power 1. Okay, that is all about this rule that you need to know. I repeat that because I'm not sure whether my picture will cover the working. So I've dealt dy dx. When I have function of y is equals to a power x, ax power of n, what I get is when I differentiate, you call this differentiation. Differentiate means I get dy dx. And remember what I told you about dy dx? Dy dx is basically finding the gradient of the tangent at a given point. Gradient of tangent at a given point. If you don't understand that statement, just memorize it first. I'll explain to you in the next few videos. Dy dx is a gradient of tangent. Gradient of tangent, don't forget. Gradient of tangent of a curve. So assuming this is a curve, how do I know what is the gradient of tangent? The function is that what I do is I bring the power downwards, n times a times x. Then the power you minus 1. That is all what you do. This is called the power rule because you have a power. You understand? This is called the power rule. And the power rule can also be further. Okay, I don't teach you that one first. I'll teach you that one when I see the questions later. Okay, so without further ado, we look at questions. Part 1 is usually on product rule, on power rule, basically. So how do I find dy dx for this first question? We do the circle questions. Dy dx, what I do is, remember, you look at them individually, not to be scared, okay? Look at that individually. So I have two. Okay, I have 2 here, right? Correct, not? This is x as power of 2. So I bring the 2 downwards times 3x. Then the power of x will reduce by 1, which is 2 minus 1. Okay, I write the full working now first, okay? Plus, whenever you have like x power 1 only, right, you can straight write the answer is going to be 6 already. When you differentiate, for example, I give you a hint here. When you differentiate, when you have y is equals to 6x, right, dy dx, when you differentiate 6x, right, what you get is just a 6. Okay, you can just memorize it. Or what is the reason is because, right, this is 1, right? The power is 1. So when I bring 1 forward, it's going to be 1 times 6x power of 1 minus 1. So it's equals to 1 times 6, 1 at left to right lah. I get 6x power of 0. What is power of 0? Means anything to the power of 0 will give you 1. Okay, so the answer is just 6. Can you see? When you differentiate 6x, you get 6. When you differentiate 7x, you get 7. When you differentiate 8x, you get 8. When you differentiate 100.1x, you get 100.1. It's basically the number in front of the x. This is one of the hint, okay? What I want to tell you is one hint is that when y is equals to ax only, your dy dx is just a only. Okay? And then one more thing, if you have y is equals to a, when you have like y equals to, for example, y equals to 6 only, it's like a constant. When you differentiate it, right, dy dx, right, is equals to 0. Okay, don't forget it's equals to 0. I can explain to you a bit using graph later, but never mind. We'll do later, okay? Okay, yep. So you remember, so when you differentiate something x, you can straight away get 6. And minus, when you differentiate a constant, you get 0. Remember, I told you here, when you differentiate a constant means when you differentiate 7, 9, 10 without x, there's no x here, okay? There's no x. You get 0 straight away. Why? Why you differentiate? I'll explain to you once, then later on I wouldn't explain anymore. Why? It's because 7 has x to the power of nothing, which is 0. X power 0 will give you 1. That's why there's no x. Okay, x power, this is actually 7 now. 7 is equals to 7 times x to the power of 0. And then when you remember, the power rule is when you have to bring 0 forward for multiplication. So 0 times 7x, then 0 minus 1. You see, this 0 will cause this whole thing to be 0. The whole thing will be just 0. You get it? What I mean? So when you have a constant, basically means a number. A number, when you differentiate a number, you get 0. Don't forget. When you have something x, when it's x power 1 only, don't forget x power 1, you differentiate, you get 6 only. Basically the coefficient in front. Basically the number in front of x would be the differentiated answer. Okay? We'll do more later. So it's equals to, this one 2 times 3 will give you 6x power of 1. This is basically your plus 6, don't forget, plus 6. Because there's a 6 here, don't forget. This is your dy dx. So basically, right, this is actually your gradient of your tangent. Basically, you've got a curve, right? This curve is actually this curve. Okay? How do I know what is the gradient at this point here? For example, how do I know what is the gradient at this point here? I want to know what's the gradient. How do I know? Is I just use this formula. I just find the x value because there's an x here, right? So what I do is I find the x value. For example, x is equals to 1. So I just substitute 6 the gradient is dy dx is equal to 6 times 1 plus 6 gives you 12. So I know the gradient is 12. Okay, and you know positive gradient means it's actually in the upwards direction, going upwards the slope. So it's correct. Okay, this is a way to test it. If you don't understand anything, try to watch my previous video if you don't understand this. Why is it positive and negative gradient? Basically, you don't have to watch. Really, what you have to know is when you go up slope, it's a positive gradient. When you go down slope, it's a negative gradient. Okay, up slope is a positive gradient. It's a way for you to check your answer. Down slope is a negative gradient. All right, the next question we do is number 3. Okay, whenever you see there is x in the denominator, what you do is you bring it up first. How you bring it up, I show you up. Y is equals to 4x squared. I just rewrite. I haven't differentiated yet. Why? Because I'm writing y, not dy dx. I haven't differentiated anything yet, okay? So I do y is equals to 4x minus, I try to bring this one upwards. Remember in your indices rule, I can bring this upwards by actually changing the power of this 3. What I do is 3, I can bring it upwards. Now it's no longer downwards, but I just change the sign of the 3 because minus 3. Understand? Minus 2, one more time. 2, I bring this x upwards. What I do is I have x minus 2. Basically, this 2 becomes minus 2. This 3 becomes minus 3. Okay? So I've shifted it upwards really. Basically, what I mean by upwards is no longer in the denominator. It's not up there already. It's now beside the 3 now, beside the 2 now. Okay? It's no longer in the denominator. All right? So what I do is, I repeat, I just bring it upwards and I change the sign of the power. Okay? So why I want to do it? Because now I can differentiate now already. So when I differentiate, don't forget 2 bring forward times 2 times 4x the power minus 1. There are 2 things I did. I bring the 2 for multiplication. This is the first thing I did. The second thing is a minus 1 for the power. Okay, then minus, same thing. So why did we want to bring the x upwards? Is because so now that this is the power I can multiply in front. Okay, minus 3 times, this 3 is this 3 times minus 3. Why I have minus 3? Because this power I have the times in front. Then x, copy back x, minus 3. I have to minus 1, the power I have to minus 1. Don't forget, there are two things I did. As I mentioned, what I did is I bring this, wait, let me repeat this part again. I'll repeat this part. Minus, what I do is I bring this power, remember, don't forget, bring the power forward, which is negative 3. Then you times back the whole thing, 3x power of minus 3. But just that you have to minus the power with 1 more. Okay, there are two things I did, I repeat. One is I minus the power with 1, and I times this negative 3, which is the power originally here. Okay, in front. That's what I do. Okay, so then I minus, same thing. What I do is I times the power in front, minus 2 is the power, don't forget. Then I times, copy back to x power of minus 2. But what I do extra is a minus 1 extra power. This is what you do. You shift in front the power, then later the power you minus 1. Shift in front the power, then later the power you minus 1. That is what you do. Okay, so what I do is I multiply 2 times 4, constant, I get 8x, 2 minus 1 gives you 1. Okay, this is minus times minus, so I get plus. 3 times 3 gives you 9. X minus 3 minus 1 gives you minus 4. Okay, so this is minus minus is also plus. 2 times 2 is 4. X to the power of minus 2 minus 1 gives you minus 3. Okay, so actually, right, 8x, you want to bring this negative 4 down, also can. So this one to do reverse, right? When you want to bring it down to the denominator, what you do is plus 9 over, you just change back the sign to 4. Basically, when you want to bring down the denominator or you want to bring up the denominator, you just change the sign of the power only. Okay, the x becomes power 4 instead of negative 4. Plus 4. If you want to shift it to the denominator, this thing you want to bring it to the denominator, you just change the sign of the power, x power 3. You get what I mean? Basically, okay, for example, a over x power of 10. How do I bring up? I just change the power ax minus 10. I just change it to minus 10. Okay, similarly, how do I change this back to this one? What I do is I bring it to the denominator and I change the sign, which is 10, which is same as this one. Okay, that's the idea, okay? I want you to know how to do it. Okay, so this is one trick you can learn. This number 3. What's the next question? I'm supposed to do number 5. Okay, when you see questions like this, right? When you see you're able to divide them one by one, you divide them first. Okay, actually this question you can solve it using other rules also. But the simplest rule is actually to use power rule. You try to divide them first. Why can I separate them? Can I separate them into this one minus this one plus this one? You can. Why? Because remember I told you a plus b plus c over 2 is equals to a over 2 plus b over 2 plus c over 2. Basically, when you have top plus minus, you can separate them. So what I get is I separate them first. Y is equals to top plus minus are not bottom plus minus are. When top separated by plus minus, you can. What you have is you have x cubed over x squared. I separate them minus 3x squared over x squared plus 4x over x squared. So I have y is equals to, you have power of 3 here, power of 2 here. So you minus the power, you get x power of 1 left. Minus x power of 2, you can actually cancel them exactly the same, minus 3 plus x power 1, x power of 2. When you minus the power, because it's same base, remember indices and logarithm I taught you, same base, you minus the power, you get 4 of x out of 4, x to the power of negative 1. Why? Because this is top is 1, bottom is 2. So when it's division, you minus the powers. 1 minus 2 gives you minus 1. Okay, so I'll rewrite y is equal to x minus 3 plus 4x minus 1. So what happens when you differentiate dy dx? Remember I told you when it's only x, right? When x is power of 1, right? Just take the number in front of it. This number is 1, don't forget. There's always a 1 in front of any unknown. For example, a is actually 1a. B is actually 1b. AB is actually 1ab. Similarly, x is actually 1x. So you can take the number straight away. Remember what I told you? When it's just x only, when x is power of 1, you can just take the number in front of it once you want to differentiate it. When you want to differentiate x power of 1, you just take the number in front of it. I repeat, when you want to differentiate x to the power of 1, take the number in front of it. And when you're differentiating a constant, you see this one has no x. Just now was x power 1. This one is no x at all. So no x, you get 0. That's what I mean. You get 0 as after you differentiate. Plus this one. Okay, this is not x power 1. This is not x power 1, and this is not a constant also. So this one you have to differentiate. So what I do is I bring the negative one in front, then I copy back 4x minus 1. What I do with the power, I just minus 1 more. Okay, what I do is I bring the power in front, then I minus the power in 1 more. That's it, how I differentiate. So what I have is equals to dy dx equals to 1, 0, I don't have to write. Plus minus gives me minus 4x minus 1 gives you minus 2. Or I can write it as 1 minus 4. When you want to shift this x down there, you want to shift the x into the denominator because now it's on top. Okay, how I know it's on top? Because it's next to the 4. When I want to bring it to the bottom, what I do is I just change the power of the sign. What I do is I change the power of sign, which is x 2. You see, just now was negative 2, now it's positive 2. Okay, and note now, I'm just doing it for x only, so the 4 will remain on top. Can you see the 4 is on top? Okay, the one bottom. If I want to bring the 4, right, just for mathematical purpose, if I want to bring this 4x minus 2, right, if I want to bring the 4 downwards, also can, okay? What I do is, the bottom will have now, you see 4 is to the power of 1. This is for you who ask me, who would want to ask me, what if I want to bring the 4 down as well? Can, but you don't have to do it in the exam, but you want to learn it extra, can. What you do is, remember I told you this 4 power of 1, if you want to bring the number, if you want to bring anything downwards, you just change the sign of the power. So you have 4 to the power of negative 1, and then x, it was power of negative 2, so when you bring down, it is x power of 2. Just change the sign, basically. See, 1 become negative 1, negative 2 become 2. And then what is left on top? Nothing, so I put a 1. Okay, this is not what we want to write it in terms now, because this is very ugly, this is nicer. But if you were to ask me, this is correct or not? Yeah, this is also correct. You understand what I mean? You can do this actually. Okay, so this is actually teaching you how to convert top and bottom. Top and bottom, you want to throw top to bottom or bottom to top, you just change the sign of the power of that thing. Okay, for x, I do for x only, don't kacau 4. If you want to do 4 also, you have to shift the power of 1 to negative 1, as I explained earlier. Okay, so I've differentiated. This is actually the correct answer. Oh, I made a mistake here. This should not be negative 2. This should be only 2, x power of 2. Okay, because remember I changed the sign, negative 2, I changed the sign to 2. Why? Because I'm throwing from top to bottom. Here is actually a top, here is actually bottom. So when I throw top to bottom, I just change the sign of the power. Plus 2 become minus 2, minus 2 become plus 2. That's it. All right, that's number 5. Okay, number 6 is a special question, not a special question. It's actually power rule. Why? Because I see a power outside. But it's actually part of chain rule. So what is chain rule? I will teach you chain rule in the 4th video of this 2.2. Okay, but I just want you to memorize the method on how to do it first. Maybe in chain rule later, I explain to you why we actually do it. Okay, so when you have y is equal to something in a bracket to the power of something, you can use power rule. Okay, you want to use power rule, can. But what you have to do, right? Remember what I did for power rule is make sure there's no x in front. There's no x in front. One thing I want you to make sure is there's no x in front. Okay, so what I want you to do is dy dx straight away, you apply the same thing. This is something to the power of 5, right? What you do is you do that thing, same thing. You do the same thing, which is what you would have done. Shift 5 to the front. So you have 5, then you copy back 6x minus 3, power of 5, then you minus 1. Okay, the red color is what I've done. And then what else you have to do is you have got to times, I put dot as times, times the differentiation of the one in this bracket, times the differentiation of the thing inside the bracket. When you differentiate inside, what do you get? When you differentiate inside, what do you get? Just look at this bracket now, inside the bracket, okay? I repeat, inside the bracket. Differentiate inside the bracket. So what happens when you differentiate inside the bracket? When you differentiate 6x, you get 6. When you differentiate negative 3, you get 0. Okay? Basically just that. Okay? One extra step you have to do is this thing only, okay? You have to differentiate what is inside the bracket. This is actually chain rule. I will call this the power chain rule because you got to type something at the back. I explained to you this why we use power chain rule in the chain rule video or some other videos. Okay, but for now, I want you to just remember, you just do the same thing as what you do in power rule. You bring the power forward for multiplication, then you minus the power with 1. But if you have the bracket like this, you have to times the differentiation in the bracket at the end. Okay. I don't know whether I should, wait, let me see. Should I include for you this thing? Okay, that doesn't matter. Okay, so what is my answer is to have 5 times 6x minus 3 to the power of 4 times with 6. So 6 and 5 can multiply each other, gives me 30, 6x minus 3 to the power of 4. See, don't forget that the power will always reduce by 1. Don't forget that. For power rule, the power will always reduce by 1. So this, I call it the power chain rule. I write it in green. Okay, power chain rule. Okay, 7, do one more time. So what I do is, don't be scared of this -5. What I want to do is, as long as there's no x outside of the bracket, okay, one condition now, write down now, one condition now. Condition for all this kind of question, power chain rule is no x outside of bracket. Don't forget. Okay. So how do I do this question is dy dx. Okay. For this question, I wouldn't write dy dx. Why? Because they didn't give me y equals to something. They gave me fx is equals to something. But it's the same thing. Instead of writing dy dx, I write f prime x. F prime means you differentiate one time. It's the same thing, okay? It's the same thing. These two, it's the same thing. But since they give me fx, means I'm going to use this version. So f prime is a comma, like a prime apostrophe. F prime x means I differentiated already. F prime x is something like dy dx is equals to, remember when power rule, what I do is I bring, first step is power in front. So this 4 power in front, then I copy back everything, minus 5, 2x plus 1, power of 4. Then what I do is I minus the power with 1. And don't forget, I've got to multiply with the differentiation of the inside bracket. Differentiation of inside bracket, what do you get? It's just 2. Why is this just 2? Because when you differentiate 2x, you get 2. Remember, I told you when x is power of 1, you differentiate it, you get the number in front only. And when you differentiate a constant, means a number only without x, what you get is the differentiation is just 0. So plus 0, I don't write at the back. It's just 2 at the back. So what I have is -20, or if you want to do it fast, 4 times -5 times 2. These three numbers, I can multiply them together. What I get is -40 times 2x plus 1 to the power of 4 minus 1 is 3. This is actually a differentiation process. This is actually your answer. Okay, now we do question number 8. I missed out 4, I think. Did I miss out 4? Yeah, I think I missed out 4. So let's do 4 first, okay? If not, 4 would feel lonely. So since it's y, I write dy dx. Okay? Dy dx is equals to, when it's power of 2, 2 bring in front, 2 times 3x, 2 minus 1. I hope that you are used to the process already, okay? 2 bring in front, then the power minus 1. Oh, I shouldn't do it first. I shouldn't differentiate straight away first because this x is bottom. We don't like the x to be in the bottom when we want to differentiate power rule. We want the x to be on top. So y, I rewrite first. I haven't differentiated. That's why it's y, not dy dx. 3x squared, I'm just copying, minus 6. You want to change this on top, just change the power, the sign of the power of x. Okay, what I do is you just change the sign of the power. This is 3, becomes -3. Okay, because I'm shifting bottom to top, denominator to numerator. Similarly, if you want to change from numerator to denominator, also change the sign of it. That's it. Okay, simple. Okay, now I can differentiate. Let me use blue because green is a bit awkward. Dy dx is equals to, okay, don't forget, bring 2 in front, 2 times 3x power of 2, then don't forget minus 1. These are the two things I did, which is times 2 in front and then power minus 1. Similarly, minus this same thing, power bring in front, minus 3 times with 6x minus 3 minus 1. Okay, these are the two things I did for power rule. Power rule, don't forget, you do two things, bring the power in front and the new power minus 1. Okay, I just off my. Right, okay, still able to see. Is it still recording? Let me check this because I've just accidentally. Yeah, still recording. Okay, so now what I do is I just solve it. I just simplify it. So 2 times 3 gives me 6x. 2 minus 1, I give me 1, power of 1. So minus minus gives me plus. And then 3 times 6 gives me 18. Then I have x to the power of minus 3 minus 1 is you minus 4. I minus $3 and I lost $3 and I lost another $1. So I lost $4 in total. So it's a minus 4. So I get 6x because power of 1 I don't have to write. Plus, remember this is in the numerator now. Basically it's on top now. How do I shift it to bottom? How do I change it to bottom? Is I change the sign of the negative. I change the sign of the negative 4. 18, I'm not doing anything, so 18 remains on top. What goes bottom is the x. So what I have to do to change it to the bottom is I change the sign. Negative 4 becomes 4. Okay, positive 4. Or 4 only. Okay, so this is, oh my lord, I just accidentally off my iPad again. Okay, so this is correct. This is what I wanted to do. I apologize if I'm speaking a bit softer today because it's already very late. It's like past 12 a.m. now. Okay, because of Olympics. So I delayed my filming. Okay, let's do number 8. Number 8, you see, right, is something like power rule. Okay, it's something like power rule. But you know that this is the power chain rule. Remember I told you? Power rule is when you have x only x power something. But power chain rule is you have when you bracket something. You have a bracket to the power of something. Okay, so this is the power chain rule. Okay, power chain rule. Power chain rule is when you have a x plus n power of a plus p power of q, something like that. Okay, so what you do, right, for this, right, is you want to differentiate it is f prime x. Okay, because this is fx given to me. They didn't give me y equals to something. They give me fx equals to something. So when I differentiate, I write in their format f prime x. I don't write dy dx. Okay, dy dx you only write when they give you y equals to something. I repeat up many times. So f prime x is equals to what I do. Power rule, as I said, power chain rule, bring the 5 down for multiplication. So I have a 5 in front here. Then the rest, I just copy everything from front to back. Copy everything, 2x squared minus 3 power of 5. Then what I do to the power is a minus 1. Okay, and don't forget, since this is a power chain rule, you got to multiply with something at the back, which is the differentiation inside the bracket. Basically, when you differentiate inside the bracket, what do you get? Just look at this bracket inside. Okay, 2x squared minus 3. Just differentiate inside. So how do you differentiate 2x squared? Is I bring 2 to the forward. I get 2 times 2x to the power of 2 minus 1. Remember, I have to minus this power 1 later. Basically, what I'm doing is I'm just differentiating inside the bracket. So 2 times 2x, 2 minus 1. And then when I differentiate negative 3, what I get is 0. Remember, I told you when you differentiate number without x, you'll get 0. Okay, so now I've completed my differentiation. So I just arrange it. What I get is 5 times 4 gives me 20 times 2x squared minus 3 to the power of 5 minus 1 gives me 4. So times what? Times 2 times 2 gives me 4. X to the power of 2 minus 1 is x to the power of 1. Okay, this 4 I can multiply in front because everything is multiplying each other. You see, multiplying each other, multiplying each other. So I can bring the 4 in front for multiplication. So 20 times 4 is equals to 80. 2x squared minus 3 to the power of 4. Then don't forget there's an x at the back. You just brought the 4 for multiplication. You still have an x at the back. So to look better, right, what I'll do is normally I'll bring the x in front. I'll just rearrange. Basically, I'll just put the x next to the 80. So it looks better. Something like this. I did not do any operation. I'm just arranging it. Something like PQR, I change it to RQP. Something like that. I'm just rearranging, not doing anything. Okay. So this is actually so far the questions. Now we move on to this question. Okay, this is the same thing, do the same thing, exact same thing. This is a power chain rule. Don't forget, power chain rule, you cannot have x outside. Don't forget, no condition is, a lot of people do not know this. Condition is no x outside of bracket. Okay, no x outside of bracket. Basically, right, I've given you one question example already to trick you, but since I've told you the answer already, so I don't expect you to know. For example, that this question, right, you cannot use power chain rule. Why? Because there's an x outside. Okay, you must have only number outside. You see, only number outside, no x outside. So this question, right, I wouldn't solve actually. I would solve in another part. This is actually product rule. I'll teach you later on. Okay, so now if you have x like this, what you do, you can differentiate dy dx. Why write dy dx? Because they give me y. If they give me fx, I write f prime x as a differentiated form. So dy dx is equals to, don't forget, when you want to start differentiating, power rule, 4 bring in front. So when 4 bring in front, I have a 4, then copy everything to the end. -3, 2 minus 3x cubed power of 4. Okay, then the power -1, don't forget. Then, don't forget this is a power chain rule, so I've got to do something at the end. I've got to times the differentiation of the inside bracket. Okay, inside the bracket, you know where's the bracket, right? This is the bracket. You've got to differentiate what is inside this bracket. Only this bracket, the rest don't have to care. Only this bracket that has power, you care about it. You look at what is inside the bracket. When you differentiate 2, you get 0, because I told you when you differentiate a constant without x, you get 0. So when you differentiate this term, okay, do it slowly. First off, you bring 3 forward. Okay, you bring 3 forward, I get 3 times -3. I copy back x, then the power -1, 3 minus 1. So I get 3 times -3 give me -9, x to the power of 2, because 3 minus 1 is 2. So this is my differentiation working slightly. Okay, so I've got to times the differentiation inside, which is this one, -9x squared. Okay, this is the extra thing that you got to multiply when you're doing power chain rule. Okay, that's the only difference between this one and the power rule. Okay, since you're a beginner doing, right, I don't want to explain too deep to you all. If not, I can explain to you actually why you do this and why you don't do it for the other side. I can explain to you, but I'll do it progressively, okay? I don't want to throw everything to you and you just get so blur, oh, I don't like this teacher anymore. He's trying to be too smart. I don't want it to be that way. I want you to learn and understand together. And certain things you can understand yourself as you move on. You try to learn things yourself. Okay? So what you have is the answer is you have 4 times -3 will give me -12. Copy back everything, 2 minus 3x cubed. And then the power on top, 4 minus 1 will give me 3. Then I times with a -9x squared. Okay, this number, -9, I can multiply in front with -12. It will give me positive 108. 2 minus 3x cubed times with x squared. Don't forget, I just multiplied the -9, but there's still an x squared at the back. Don't forget about the lonely x squared at the back. So as I said again, I like to rearrange it to 108x squared. I like to bring this x squared in front and tuck it in between this 108 and the bracket. So I just tuck it in front, then I write the bracket 2 minus 3x cubed. Okay, so this is the answer. So don't forget, what we have learned actually is 2 things. One is the power rule, one is the power chain rule. And when do you have power chain rule? Is when you have a bracket to the power of something, x plus maybe 5, power of maybe 10, and then you have a number in front, 3. This thing cannot have x, no x, don't forget, for power chain rule. Okay, that is why number 10, we cannot use power chain rule. I will solve the wrong way first, that will cross everything nicely. I'll do very fast because this is the wrong one. dy dx, if you did not know, right, if you didn't learn, if your teacher didn't tell you anything, what you do, oh, Brian, or my teacher told me power bring in front, 2, copy back everything, 4x minus 3, power minus 1. So 2 minus 1 is 1. So then I times the differentiation inside, I'll get 4 only. Or then the answer is 8x, 4x minus 3. I'm doing very fast because it's wrong. And this is actually wrong. What I'm doing, this is actually wrong. This is wrong. Wrong. Why? Why? Because of this thing. You cannot have that. You cannot, oh my God, cannot have x outside the bracket. I repeat many times because this one I didn't know. Why I repeat so many times is because I didn't know this one last time. Okay, I made mistakes before. Then only I learned. So how do we solve this? You learn in the next part where you use product rule. Okay, don't worry. Once you learn product rule, when you see this thing, it's just so simple. So I will cover everything in the next part under part 2. Basically, part 1 is all about product rule, except for question 10. Because question 10 is there to trick you. Okay, when you have an x outside, can you use power chain rule? Cannot. I don't forget. Cannot. Right. So part 2 is all about product rule. I'll teach you how to spot product rule and what is the formula to do it. What's the formula to do it? Okay. With that said, actually, I want you to practice. As I repeat many times, I want you to be able to. Once I've done everything already, I don't know whether you're printing my notes out or you are actually using iPad or you are doing whatever it is, or you're maybe referring to my notes and using your paper to write notes down. Anything is possible as long as what you do is you understand what I'm teaching you clearly, such that How do you know you understand clearly? Not once you don't look at my answers, my solution, you are able to do exactly the same thing. If you're not that good yet, make sure you keep rewatching, keep understanding, keep asking questions until you are that good. Until how good? Basically, you can actually not look at the solution and you'll be able to know, oh, this is type 1. I know how to do this question. What I do is I just bring the power in front, then I minus the power, then I times the differentiation inside the bracket. You do things, I straight away know. Okay, and I'm able to work out the solution step by step until I get the answer. Okay, that's very important, especially for first principle, for the last video on first principle, because that is very hard. If you do this and you look at first principle, this is so simple, I think, to you. You just need to practice more questions. Okay, so that is end for this first part. All right. Anything, we will move on to the second part only we discuss. Okay, so with that said, I stay safe until we meet each other in the next video. Practice enough first, this part. All right, stay safe. Bye. Ciao.